In this video, we're going to do some guided practice on the 2019 exam question on Bohr's theory. This was the question. It's, as you can see here, it's a 25-mark question, so it's half a full question, and this means the timings for this is about 10 minutes. At this stage, hopefully we have learned to put on our timer and just try and keep it under the 10 minutes. So what we're going to do at this stage, we've done a few of these questions together. What I'm going to say to you at this stage is, if you have a quick glance through that question, do that now, please. If you think you can manage that question, you can go ahead, pause the video, and try and finish the question down to the end by yourself. If you don't think you can do that, then wait for me or play the video for a little bit of help, a little bit of clues to help you read it, help you break it down. Okay. All right. So again, I'll give you another opportunity to pause it if you're ready to go ahead and do the whole question. Okay, if you're not ready, I'm going to help you break this down. All right, let's look at part I. Okay, it says what, so that's the command word. What is meant by atomic energy level? Okay, so very quickly, what we're doing here is in part I, we're explaining the term energy level. Okay, so it's a definition basically. So pausing the video now and writing down the definition or the explanation for what an energy level is. Okay, so what we should be saying here is energy levels are fixed values of energy that an electron in an atom may have. Okay, so I'm reading back over my answer. Fixed value of energy that an electron in an atom may have, and that is the definition for energy level. So checking the question, I'm pretty confident about that. Next one, give two. Make sure we do two now. Okay, give two differences between an atomic orbit, as described by Bohr, and an atomic orbital. So very similar terms, and we have to give two differences. Now, a little tip, anytime we're asked to give differences, sometimes if it's suitable, it's handy to use a table for this. So in part 2, we're going to use a table. So part 2. And we're going to be comparing an orbit, this word orbit, with the word orbital. And we're going to try and give at least two differences. If we can give more and it doesn't take too long, then we should probably try and do that. So a reminder then that an orbit, according to Bohr, was these circles around the nucleus where the electrons are. But what do the circles represent? Okay, so again, pause the video and have a go at giving two differences between these two things. Okay, so the first thing to note is that orbits, these things here, orbits are not physical rings that electrons move on. They're simply just pathways. Okay, so an orbit is just the pathway that an electron takes. So orbits are pathways that electrons take. Whereas orbitals, what's the definition of an orbital? Well, it's not a pathway. These are regions or spaces. It's a region in space. Okay, that's what an orbital is, whereas an orbit is a pathway. There's one difference. Okay, a second difference here would be the capacity of each of these things. Okay, so let's see, if you didn't write about capacity, you can write about the capacity of orbits and the capacity of orbitals. Okay, so again, you should pause the video. Okay, so you'll only be writing if you compare the capacity. All right, well, the n equal to 1 orbit, the first shell, if you like, is able to hold 2 electrons, so holds 2. But the n equal to 2 and n equal to 3, both of these orbits hold 8 electrons. The difference here is the capacity of the orbitals, they only ever hold 2 electrons. Okay, or maybe I should write only hold 2 electrons. Right, so I've got two differences. I'm going to stick a third one in anyway. Okay, And that's about how certain we are that the electrons will be found there. Okay, so compare them in terms of how certain we are electrons will be found there. Pause the video, do that now. Okay, so orbits, electrons are definitely on these shells. Okay, electrons definitely found here. So Bohr talked about fixed values of energy that electrons and atoms may have. That meant they were a fixed distance away from the nucleus. They were always on these orbits. So electrons are definitely found here, whereas orbitals, we know what they are. They're regions in space where there's a high probability of finding an electron. So high probability the electron will be there, but that's not definite. High probability electron will be found here. Okay, so that's 3. It asked for 2, so I'm pretty confident about that now. Next bit. Interesting. Use diagrams. So you must use a diagram because that's what it directs you to do, to distinguish. And this word means to show the difference. Okay, between a p orbital and a p sublevel. So we need some kind of a diagram that shows the difference between a p orbital and a p sublevel. So again, I'm going to use a table to show the difference. So p orbital and p sublevel. Okay, so again, I'm going to give you an opportunity now to pause the video and try and draw some diagrams to show the difference between these. Pause the video now. Okay, well, the first thing I'm going to do is draw the shapes of the orbitals. So that's a diagram I can draw that shows the difference between them. A p orbital, well, you just choose one of them and draw it. P sublevel, well, we know what that's made of. We know it's made of all the p orbitals. So can we draw that maybe? So if you weren't already able to do this by yourself, you have another opportunity to pause the video and do that now. Okay, so you should only be watching if you definitely try to draw some type of diagram that distinguishes between these two. Okay, so the first thing I'm going to do is I'm going to draw just the one of the p orbitals. So that's it there. You will note that that's the px orbital. Whereas the p sublevel is arranged in space on the x, y, and z axes. Okay, and we know it's made, a p sublevel is made up of 3 orbitals. So I'm going to do them in red here. There is the px, there is the py, and there is the pz going in and out. Okay, so this is a bit messy, but I mean, it's still, I'm still going to get the marks. They'll know what I mean. There's another way you could have done this. Another diagram that we could use is to show the spin diagrams for just one p orbital versus a p sublevel. So can you pause the video and draw the spin diagrams that would represent a p orbital and one that would represent a p sublevel? Do that now, please. Okay, so that is, it would be like this. So a one orbital would just be one box with 2 electrons in it, whereas a p sublevel would be made up of 3 orbitals, so boxes of equal energy. And again, they can have electrons in them like this. So either of these diagrams, these 2 or these 2, would probably get you the marks here. We'll see when we go to correct it later. Okay, so that there is a diagram to distinguish between p orbitals and p sublevels. Okay, let's look at the next section. Right, so that's the command word, an electronic configuration for a nickel atom in its ground state. Okay, so we need to look at electronic configuration for nickel. All right, so part I4, we're doing nickel. We're doing the electronic configuration. Okay, so nickel, first thing to do is find out. We can't do the electronic configuration until we know how many electrons nickel has. So pause the video and look up on your periodic table, how many electrons does nickel have? Do that now. Okay, so you should have got 28 electrons. 28 electrons. Okay, so now that you have that, pause the video, do the configuration. All right, so again, you should only be watching if you've done the configuration. So let's build up the configuration from scratch. We've got 1s2, 2s2, 2p6. There's 10 electrons so far. 3s2, 3p6. There's 18 electrons so far. Next to be filled is the 4s2. That's 20 electrons so far. And then the next energy level, the sub-level, is the 3d. And there are 8 remaining for here. So 3d8. Pretty straightforward. Done loads and loads and loads of them. I'm pretty confident you guys can do that, no problem. Last question. State one piece. So with the state is the action word. That's what they want us to do. And one piece of evidence that supports the existence of atomic energy levels. Okay, so this is part 5. What is it about? Evidence of energy levels. And there are 2 main pieces of evidence that we've learned for existence of energy levels so far. Okay, so again, pause the video, and you only need 1, but can you write down about the 2 of them? Pause the video, do that now. All right, so the first one to think about is, we said, well, the whole idea of where energy levels, the idea of an energy level came from Bohr looking at emission spectra. Okay, so emission spectra is the first piece of evidence. And what about it is the evidence? Well, it's the fact that we can only have lines of specific frequencies. So lines of specific frequencies on emission spectra show electrons can only have specific values of energy. Okay, I think that's probably way too much of a sentence in this case. I think probably only a 3 marker here, so don't waste too much time. Another piece of evidence that we've seen is to do with first ionization energies. Okay, so first ionization energies from full outer shells. What am I referring to here? Well, we've seen that when we try to remove an electron from a noble gas that has a full outer shell, the first ionization energy to remove that electron is very, very high. And again, this is showing us that there's something going on here, that the electrons, once they fill up something, this is a very stable configuration. What is it that they're filling up? Well, that's the evidence there that there must be something called an energy level. When it's full, it's really hard to remove an electron from it. And we can directly measure this by measuring the first ionization energy. So there's our evidence. All right, so stop the timer. Okay, and it's time to go and correct these now. Okay, so using the marking scheme, we're here. All right, the first question asked us about what is an energy level. So what is it? We need, remember, anything in bold, we need to have in our answer. So it's discrete, definite, fixed. I think we said fixed. Fixed amount or fixed value of energy that an electron in an atom may have. That's what we had. So we got fixed value of energy that an electron in an atom may have. Yeah, we're happy with that. That was worth 4 marks. Next question asks you to compare a Bohr orbit with the word orbital. So orbit versus orbital. Okay, so the first thing is that an orbit is a pathway, whereas an orbital is a region or a space or a volume. And we could have also said that orbits are 2-dimensional, they're just round circles, whereas orbitals are 3-dimensional. Okay, so which one did we go with here? We went with the whole orbits are pathways, whereas orbitals are regions. So tick that, what each of these were, and imagine it's 3 each. Yeah, so as you can see down here, any 2 lines on table, 2 by 3. So there's one of the lines, 3 marks. Okay, what's the next bit? Capacity. Okay, so we did talk about the capacity So capacity is 2, 8, etc. electrons versus capacity of orbitals is only 2 electrons. So that's what we said. We said hold, but that means the same thing as capacity. So orbits hold 2 and then 8 electrons, whereas orbitals only hold 2. So there's my second 3 marks. That's all the marks I can get for this part. But let's just take a look anyway. As we can see, we would have got it for the third one here if we had missed out on either of the ones above. So electrons are definitely located in orbits, whereas in orbitals, there's a high probability of finding an electron. There are also other options. So if you didn't have any of the ones I had, you can go ahead and look at these other options. Did you have any of these covered? They will also get you the 3 marks. So pause the video if you need to check any now. Okay, so again, I'm happy with that. I would have got the mark here, but we've already got the 6. The next thing was to use a diagram to explain the difference between p orbitals and p sublevels. This is exactly the one we went for first. Okay, and we also have, look, here is the electron spin diagram. So either of those is perfect. And again, that is 6 marks. Okay, so again, we have the 6 marks got for that. Next one was the configuration of, which element was it again? It was, where was it? Nickel. And let's just check it out. It was split over 2 lines, so 2 parts. The first part was this bit up here, any of these versions here before that double line. So this is the one that we had in green. Okay, and then the second part was for either of these is correct. So we had it done correctly, 4s2, 3d8 first. So that's what we had. Yep, exactly. There's all the marks there. So we're getting all the marks there. I think that's what 6 is it? 6 marks. Yep. So that's a 6 mark. Okay, and then evidence of energy levels. Let's see what are the options here. There's quite a few options. Pause the video and check the options with your ones. Again, remember, anything in bold you have to have in your answer. Okay, so simply, actually, we only needed the word spectra. Okay, spectra themselves, atomic spectra, emission spectra, any of these words, absorption, line spectrum, just that really is all you needed to get the marks here, because it's only worth 3 marks. Sometimes you need more than this when they ask this question. If it's worth more marks, you need a bit more detail. So yeah, and then as you can see, first ionization energies was also an option. So we gave both of them. We definitely have them 3 marks there. Let's check our answer again. Lines of specific frequencies on emission spectra. You only actually really needed that and first ionization energies. So yeah, we got the 3 marks. We had more than enough there. So what are we at there? We're at 25 out of 25. I know that because we didn't get any wrong. This was a 25 mark question. So again, we're hopefully getting very confident with Bohr theory questions, orbitals and orbits. All right, we'll see you in the next video.